This is just a scrap piece of cardboard. We'll quickly take some help from Batman. There is no speaker cone, no enclosure, just this tiny disc. Cardboard is probably the last thing you would expect to be a speaker. But for this type of speaker, it actually works. In this video, I'll show you why this works, what doesn't, and how to build one that actually sounds good. This is the final result, and yes, it gets surprisingly loud. This is known as a DML speaker, a distributed mode loudspeaker, or a panel speaker. You can probably guess why. In a normal loudspeaker like this, the cone will displace air to produce sound. But here, the exciter will produce vibrations which get distributed throughout the panel, and the entire panel produces sound. Hence the name, a distributed mode loudspeaker, or in short, a DML speaker. I was initially planning to use this foam board for this build. But when I actually ended up testing it, it didn't perform that well. Not because the idea was wrong, but because the material and the exciter I was using. I actually ordered this foam board specially for this build. But here's the irony. The packaging it came in sounded way better. The reason is pretty simple. I'm using a very small 3-watt exciter. The cardboard is lighter and more efficient, so it gets louder with less power. With DML speakers, the material matters, but the efficiency matters even more when the power is limited. Just switching the material from the foam board to the cardboard completely changed the sound. While researching for this project online, I came across a channel called Tech Ingredients. There were two main learnings from their videos. Firstly, we need to mount the exciter in the 3/5 2/5 position, and also we need to round off the corners of the panels itself. These two changes have an audible difference on the sound quality produced. For this build, we will need a switch, an 18650 lithium ion cell, its holder, a 1S lithium ion charging board, a 1S BMS, a 5-watt amplifier board with the Bluetooth chip built in, our exciter, two carbon rods which I am using to suspend the cardboard piece, and a 3D printed base and the housing for all our electronics. As always, links to all the parts used and the free 3D files will be in the description below. You can find the detailed electrical connection diagram in the description as well. Now, let's start building it. Now we'll quickly solder on the wires to the exciter. Just keep one thing in mind, that when you're soldering the wires to the back of the exciter, just keep them coming perpendicular to the exciter, because if you make them parallel to it, then the wires might interfere with the panel itself, and we don't want that. We want to isolate the panel as much as we can. So we are going to solder it perpendicular to the exciter. As you can see, both wires are coming out perpendicular. After soldering it up, I just noticed a thing, that this 3D printed case itself acts as a pretty good medium for this build. So maybe in a future video we can test out PLA itself as a panel material. I don't This sample test worked out pretty well. I like the sound coming out of it. Now I had the cardboard panel in the final desired shape. one thing kept bothering me is that no one is going to hang raw cardboard in their living room or their bedroom. So we need to come up with a better finishing solution. What I did for that was I cut up three small pieces with three different finishings. So this one is raw cardboard, this one is cardboard with a carbon fiber vinyl wrap, and this one I spray painted black. So I cut three equal pieces of cardboard, and now I'm gonna test each one by one. So I just want to check whether any one of these two finishing has a negative impact on the sound. So after the sound test, the good news is all of these three finishes don't make that much of an impact on the overall sound. The carbon fiber finish made the highs a bit more sharp. This black paint made the sound a bit muddy and dead, I think. But that was only a minor difference, and that might also be caused due to the fact that it has only been 60 minutes since I painted this black. Maybe if I wait for a whole day, the paint will actually completely dry up and that effect would be gone. So, as a result, I think I will go with the carbon fiber finish because that will look the most aesthetically pleasing and most uniform. So, yeah, we'll go with this. To get the best sound out of this speaker, I needed to mount this panel in a way that it can freely vibrate in the air. So for that, I came up with a solution. So I made these adapters which will go over the rods like this. These rods are 5 by 5 mm in cross section, and then I will stick these two on the back, and then I can tie a thread to one of the rod from both sides, and that way it can freely vibrate in the air without any major obstructions. Now we'll tie off two pieces of thread on both sides. Before inserting these rods here, we'll just quickly add some silicone pads. The rods are supposed to just slide in these cavities. Now we can mount this panel here using the threads. I've designed this in a way so you can adjust the length. Now for the final step, we'll remove the tape from the pre-applied adhesive on the exciter and we'll stick it on the 3/5 to 5th location. And we are done. This is our final product. Let's test it. In my opinion, these are some pretty good sounding speakers. As you could hear in the sound test, the sound coming from them is not very directional. So that can be both a good thing and a bad thing. But I feel for the price you can build them, these might be the some of the best bang for buck speakers. And they look awesome too. They don't look like your usual speaker sitting in the on a cabinet. Cardboard is lightweight, well damped, and very efficient. This makes a great match for small exciters like this. Foam board can still work, but it really needs a bigger exciter. I think that's one of the beauties of panel speakers. You can get way different results from the same exciter just based upon what material you are using. So you're not just tuning the exciter, you're tuning the material to the power you have. Now, if you have made it this far, show some support and press that subscribe button. I'll keep bringing cool projects like these for you. In the future videos, I want to test more materials, maybe bigger exciters. So definitely stay tuned for those builds, and thank you for watching. Bye bye.